Thank you. Thank you. Welcome to our presentation of how to monetize AI interfaces using APIs. Because actually, that's the goal of AI, right? So if you'll notice, this is by Will Nowak. Just for clarification, I am not Will Nowak. There are storms involved in the eastern region of the United States, and so Will did not make it. My name is Chris Embry. I'm a solution architect and data monkey for 30 years or so, and I've been with Dataiku for just over 2 years and have been thoroughly impressed with everything that's going on there. But we're here to talk about ROIs. Disclaimer, this is our take on it. You may have a different view, but this is the way we like to present things and talk about how you can get value out of the models and machine learnings that you have developed within your organizations, okay? So one of the big questions that we always get asked is, why is data so important? Why does everybody talk about data? Well, data is a record of things that have happened, transactions that have processed, and it's a way that we can gain insights into what's going on in our reality, right? So in the past, we've used data for a variety of things, like improving operations, and that's really kind of boring. We've been doing that for a long time. We've been doing things like market segmentation, quarterly over quarterly, year sales by store, and that's you fall asleep in meetings like that. A little more exciting might be predictive maintenance, where you can predict something's going to fail before it does. Fraud detection, that's important to the people who are losing money in that. Inventory management, if you know that you have an inventory that you need to manage, it might be important to use data to predict those things and manage your inventory. But it's not really very sexy, and it's not really kind of new agey in the world that we live in today. So we like to talk about data-driven products, and those are things like optimized social media feeds. Some people think that might be evil. I don't know. Spotify has a thing called Discover Weekly, where they analyze your listening habits, what you upvote, downvote, and give you an opportunity to discover new music. And that's valuable because that keeps you coming back, keeps you subscribing, keeps you listening, keeps you happy. Managing real-time prices for ride sharing. Boy, I don't understand why anybody would want to do that. I mean, surge pricing, that seems kind of evil. But anyway, that's the types of things that everybody wants to be able to get to. And unless you're one of these companies that has been in machine learning and AI space for a long time, it's kind of hard to wrap your head around how to get it done. And so that's one of the things that we want to talk about here. Traditionally, what we like to talk about is you look at your data and you make a decision. That makes reasonable sense. And we've been doing that since olden times, back when things like this were chic. And in more modern times, we have things like this where we can give you the visualization of the stacked data coming together, so you can look at that and go, hey, I know what this means as a business user, and I can make a decision based on that, and then put some thing into production or into motion based on what I'm learning here, what I'm deciding. And that's great, and that's where we've been for a long time. And it sort of looks like this. And this is the old model, right? We have data, and we think about it and make a decision. And that's all good. We've got SelfService Analytics now, so you don't have to be a programmer to get access to these things. You get these fancy charts delivered to you. You can look at it as a business user, analyze it, and make a decision and put it into production. What we're looking for now is this operationalization thing, which says that, well, hey, I've got this. I know the decision that I want to make based on previous experience. Can I just make that decision happen in my world without having to sit back, think about it, and process it? And that's kind of what we're looking for, click here, where that little tiger-looking thing is supposed to be a robot, I guess. So now we want to take our data, do some machine learning, with a decision that immediately results into an action. You go, well, how does that work? Through the magic of APIs. You guys are familiar with APIs, application programming interfaces? that's a way for us to take data in, run through some process that we don't necessarily know about, and get a result out. That looks like this. This is an example of an API call where we've got some data. You can tell this was put together by a data scientist. Feature 1, a value of 1, feature 2, value of 2 goes into the API. Now that API, in this case, is a machine learning model that you've developed with your business knowledge. You've determined rules, and you say, well, if feature 1 is a 1 and feature 2 is a 2, then I know that my prediction for the output of that, and that's a really bad render, sorry, I have a 10% confidence that the prediction is 0, and I have a 90% confidence the prediction is 1. What's interesting to me about this is, again, this is a data scientist viewpoint of it, where he's sending that prediction result back to some other process to manipulate it. This could just as easily, if you notice looks like JSON code, if you're familiar with that, this could just as easily be a set of links that come back. So in your input or your data coming into your API, you've got a customer representation, whether it's a profile, an IP address, time they've been on site, whatever, and the item that they're viewing. And you can then quickly go out and get some recommendations and even provide the links right there so that your output might go directly as an input to a website, and you're showing additional products that the consumer might be interested in. So now we're going to talk about productionalization in general, because this is how we want to productize this model in this API call. So when you produce something, first you have to produce it. I've got a widget, it's great, I think everybody's going to want my widget. You package it, you put it in a little retail packaging, and you're ready to have it consumed by the masses. You ship it out, it sits in stores, people use it, and in a perfect world, you get quality control feedback so that you understand that the people that use this widget, they either loved it and it was great, or there's this consistent problem. And so you can use that quality control feedback to refactor your product, or in the case of machine learning and AI, refactor your model. I don't like this slide. We'll come back to, this is basically an example of that recommendation engine. We've got a customer that's doing 4,000 B2B clients, and they have developed a recommendation engine, and it pops the items in their section of their website right there. This is just one of the things you can do. So, so how does this happen? So traditionally, what we've seen is we have trade specializations. You can pick who you want to be the data scientist and who you want to be the business user here, but basically, each one has their specialization. The data scientist knows things about Bayesians and random forests and things like that, and your business user knows about consumer reception to products. And so getting those guys to work together is a good thing, but it risks being siloed in your little organizations. What if you have a business user who actually wants to learn R programming, or can do enough of the development that he doesn't need to rely on a data scientist? How can you enable them to do that? What if you have a data scientist who really has good business knowledge and you want to enable him in the same place? So in our productionalization model, we produce a model, or we produce a Python function. We document it, we package it up, and we schedule it for transport through our APIs. And we ensure it's up to standard through continuous model feedback and model drift monitoring. At Dataiku, we like to walk the walk for APIs. We have a public API so that you can actually you can manipulate our interface, do things outside of our UI, which is actually pretty cool, but it allows you to do things like automate the non-automated stuff. So a couple of case studies here. We have a data science as a service client who's a cloud-based sales customer relationship management company, and they wanted to develop a data-driven, customized user experience based on the customer's data. Well, they had many customers, and their customer data was different for each one, so they had to have a different customization. What that came down to was something that looks like this. They knew the features that were important. Now, the feature values for each customer were going to be different, but they were able to develop the model so that the features drove the output by the input. So here we've developed this main model engine, and then when we push that out for customer A, project A, and customer B, they have different input data sets. That model is going to produce different results based on the different input data sets and deliver a different user experience for each of those customers because of their data that those customers are providing. What's nice is those services are different services, and they can live on the same nodes and be hosted at the same time without additional infrastructure costs. So this is just one example of something that a customer of ours did a couple of years ago, I think. And the idea was that they were able to provide real-time on-site assessment. Sorry, this is the second use case in the slide I actually edited, but it didn't make it to the presentation. The second use case, we have a digital security provider that wanted to provide real-time on-site assessment of fraudulent IDs. So they get an ID, they scan it, they have a template that they are able to determine whether that's a Nevada driver's license, a passport, other state driver's license. And then based on that, they submit a request for machine learning to determine whether it's fraudulent or not. They send the prediction back, but they also anonymize it and then store it in S3 so they can go back and refactor. They send the low confidence results off to humans to analyze them. And then based on the predictions and the human results, they send feedback back to the model, retrain the model, and the model gets smarter every time they're able to do this. There are ways that you can do this on a batch basis. We now have some plugins that allow you to do this on a more automated real-time basis. And no matter what you're putting into production, we have a couple of deployment options here. You can deploy it into dedicated API nodes where they are clustered and they're virtual machines running software to handle all the REST calls. We also can push those off to Kubernetes clusters, whether that's existing on-prem K8s or EKS if you're in the Amazon world. And so what that looks like from our point of view, we're an end-to-end, is you have your data selection over here, whether your data is living on S3, on-prem, and Hadoop cluster, SQL data stores, we don't care. We provide you both visual and coding recipes to manipulate, wrangle your data, clean it up before you actually try to perform any machine learning on it. We give you the ability to train and score models so that you have a champion model that comes out. You can run model competitions to see which one fits best, and then deploy that out so that it's consumable by your websites, other inputs, so that it's just a RESTful call. I want to switch over and just give you a quick example. We still have 5 minutes of that. All right, so this is this is our data scientist studio that our data scientists use all over the world, and it's messy, but we have an example of a testing project that we created so that when we installed our software on a new client, we had the ability to test all the features. So what's interesting is we're talking about collaboration. Remember the data scientists and the business users, they can come together here in this environment and they can work together on this at the same time. They can share notes, they can give each other to-dos, there can be checkoffs, there's whole conversations that can be had. But at the end, there's a workflow. See if I can zoom out on that a little bit. I love the zoom. At the left side, you've got data inputs, you've got processes that happen to the data to clean it up, make sense. And those, again, can be a combination of visual and coding recipes. Anything you see over there on the right in the orange is actually code. And at the end of the day, you get outputs that result in something that you want to present. Going back to the APIs, when you are ready to create an API, hit the API designer. I'm going to create a new API service, AWS demo. And I create my first endpoint. I'm going to give it a name. And what's really nice here is this can be a prediction model. It can be a custom Python, custom R function, Python function, SQL query. It can be a lot of things. The nice part is that once you have created the model, which you've created the business intelligence, you don't have to worry about the nuts and bolts of how do I make this a RESTful call? How do I make this something that my web users can call and get results from? By creating this and publishing it on our site or on your Kubernetes cluster, we've taken care of all the busy work for you. You don't have to worry about pickles and jar files and things that you might have to worry about otherwise. All right, so it's time for questions. Any questions?
And if anyone does have a question, I'll happily bring you the microphone if you'd like, so you can be heard. Just raise your hand.
I think the fundamental impression that we want you to have is that it doesn't have to be batch anymore. We have the ability to process things through APIs and make it real time. And if you'd like to learn more, come see us at our booth, visit our website, come see me.